This is the third and final class on the endocrine system. If you haven't seen the other two, go check them out. If you have, let's get going. Welcome, students and curious minds. I'm Tarek, and today we'll discuss the glands in the endocrine system. We'll start with one of the most well-known glands, the thyroid, which is located in the throat and is responsible for producing thyroxine and triiodthyronine. These hormones are involved in metabolic processes like cellular metabolism, weight maintenance, body heat, growth, and heart rate. The thyroid also produces calcitonin, which helps lower calcium levels in the blood. There are some important and relatively common changes that can happen in this gland. Hyperthyroidism, which is when the thyroid is overactive, speeds up the metabolism overall. The heart beats faster, body temperature gets higher than normal, and the person loses weight because they burn more energy. On the other hand, we have hypothyroidism, which is when the thyroid works less and produces less thyroxine. As a result, the metabolism becomes slower. Some areas of the body become swollen. The heart beats more slowly, blood circulates more slowly, and the person uses less energy, tending to gain more weight. Also, both physical and mental bodily responses become significantly slower, and if left untreated, it can cause a goiter. Either of these two conditions is extremely hazardous to your health and must be treated immediately. Next, we have the parathyroid, which are four distinct and very small glands located behind the thyroid. They produce a hormone called parathyroid hormone, which is responsible for ensuring a steady increase in calcium levels in the blood. A decrease in this hormone can reduce the amount of calcium and cause some muscles to contract violently. Next, we have the adrenal glands, which are located above the pancreas and are divided into two parts. In the cortex of the gland, aldosterone is produced, which ensures the reabsorption of sodium, and cortisol, which causes an increase in the concentration of glucose in the body. In the medulla, which is the distinct internal region of this gland, adrenaline is synthesized and released, which promotes cardiac stimulation and increases blood glucose levels. Noradrenaline is also produced in this part, which mainly is responsible for facilitating the constriction of specific peripheral blood vessels throughout the body. Next, we have the pancreas, which is a gland about 15 centimeters long, located between the duodenum and the spleen. It acts on both the endocrine and digestive systems, mainly due to its ability to produce enzymes, proteins, and hormones. Since it is a gland, it has exocrine characteristics for the digestive system and endocrine characteristics for the endocrine system. For the endocrine system, it produces insulin, glucagon, somatostatin, and amylin. Insulin is responsible for lowering blood glucose by promoting its entry into the body cells. In addition, it is important for carbohydrate metabolism. Its absence can cause type 1 diabetes. Glucagon is a hormone responsible for carbohydrate metabolism, and it also increases the glycerin level, counteracting the effects of insulin. In fact, they work together, each regulating the other. Somatostatin is also released when there are high levels of glucose and glucagon in the blood. It plays a role in regulating blood glucose and modulates the secretion of insulin and glucagon. It's worth noting that this hormone is also released by the hypothalamus, and in this case, it prevents the secretion of growth hormones. Finally, we have amylin, which also synthesizes glucose in the blood, and its absence can cause type 2 diabetes. The next gland is the ovaries, which are glands found only in women and are capable of producing female gametes, the eggs. Now, regarding the endocrine system, we can say that it produces estrogen, which acts in the development of secondary sexual characteristics and promotes the growth of the endometrium. We also have progesterone, which promotes the growth of the endometrium. Estrogens are essential steroid hormones that are secreted by the body on a constant basis, and their levels show significant and distinct variations at different stages of life. During the embryonic stage, they mainly act on the development of the uterus and the vagina. From birth until puberty, their secretion is low. However, starting at puberty, there is a sharp increase in secretion due to stimulation by hormones from the pituitary gland. They mainly act on the development of sexual organs, as well as secondary sexual characteristics. They stimulate the development of the fallopian tubes, the uterus, the vagina, the external genitalia, and the breasts. In the pre-ovulatory phase of the menstrual cycle, the estrogens produced by the follicular cells stimulate the proliferation of the endometrium and the glands located there, whose function is to support a future embryo. Progesterone, on the other hand, is a steroid that prepares the female body for pregnancy. It forms the endometrium, which will serve as the site for embryo implantation, and it also takes part in the formation of the placenta, which is important for nourishing the embryo. This hormone also decreases uterine contractions, preventing the expulsion of the embryo. It increases secretion in the fallopian tubes, producing nutrient material for the embryo. In addition, progesterone will stimulate the development of mammary glands and inhibit the production of FSH by the anterior pituitary, which will prevent the development of a new follicle during pregnancy. Finally, we have androgens, which are steroids with a masculinizing effect, and are also normally produced by the ovaries in small amounts. They are also produced by the adrenal gland. And since we talked about ovaries, we also have to mention the testes, which are the male sex glands and are located in the scrotal sac. They are responsible for producing the male gamete, the sperm, and just like with the female, there will be a dedicated lesson about it. In addition, they are responsible for producing testosterone, which plays a critical and essential role in sperm production and in the development of secondary sexual characteristics in the male body. Finally, we have adipose tissue, which is a type of connective tissue that has the ability to store fat through specialized cells called adipocytes. In addition, these adipocytes can synthesize and release a wide and diverse range of peptides and non-peptides, as well as efficiently store, as well as mobilize triglycerides, retinoids, and cholesterol. I hope you enjoyed the video. Don't forget to like and share, and remember that we have a new video every week, so subscribe to the channel and turn on the notification bell to always get the latest updates. Thank you so much.